Python has become the lingua franca of ethical hacking due to its versatility, readability, and vast ecosystem of specialized libraries that empowers security professionals to conduct penetration testing, vulnerability assessment, and digital forensics with remarkable efficiency. At the forefront stands Scapy, a powerful packet manipulation library that allows ethical hackers to craft, send, and analyze network packets at a granular level, enabling everything from custom port scanning to sophisticated man-in-the-middle attack simulations without relying on pre-built tools that might trigger security alerts. For web application testing, requests paired with BeautifulSoup forms an indispensable duo. While requests handles all HTTP protocol operations with elegant simplicity, BeautifulSoup parses HTML and XML documents to automate web scraping, form submission, and analysis of web application structures essential for identifying potential injection points or insecure design patterns. The PyCrypto and Cryptography libraries provide cryptographic primitives that allow security professionals to implement and analyze encryption algorithms, crack hashes, and test the strength of security implementations, with cryptography's maintained status making it preferable for modern projects requiring TLS/SSL functionality, or X.509 certificate manipulation. Impacket stands out as a collection of Python classes focused on low-level network protocol interactions, particularly useful for crafting and decoding network packets in Windows environments, enabling ethical hackers to simulate attacks against SMB, MSRPC, and other Windows-specific protocols during penetration tests. For brute force attacks and credential testing, Pwntools offers a comprehensive framework that simplifies exploit development and interaction with vulnerable services, while Paramiko implements the SSH-v2 protocol, allowing automation of secure connections and testing of SSH server configurations. The Python-Nmap library bridges Python's flexibility with the powerful Nmap security scanner, enabling programmatic control over network discovery and vulnerability scanning operations that can be integrated into larger security assessment workflows. Socket deserves special mention as Python's built-in low-level networking interface that forms the foundation for many security tools, giving ethical hackers precise control over network communications when developing custom scanners, proxies, or network monitoring solutions. For malware analysis and reverse engineering, Pefile allows inspection of Windows PE files to identify suspicious imports, sections, or other potential indicators of compromise, while PyREBox provides a Python API for building custom reverse engineering sandboxes. PyInstaller Extractor serves a unique role in analyzing potentially malicious Python executables by reversing the PyInstaller packing process to reveal original source code, invaluable when investigating suspicious Python-based tools encountered during security assessments. The Selenium library automates web browser interactions at a sophisticated level, enabling ethical hackers to test for advanced client-side vulnerabilities, session management flaws, and complex multi-step exploits that require precise timing and interaction sequences that simple HTTP libraries can't replicate. Specialized libraries like PyLDAP facilitate testing of directory service security by providing programmatic access to LDAP operations, while PySocks implements SOCKS proxy support crucial for conducting security research through anonymizing networks like Tor. For forensic investigators, Volatility stands as a memory analysis framework written in Python that extracts digital artifacts from RAM dumps, crucial for identifying malware persistence mechanisms or investigating advanced attacks that leave minimal disk footprints. Pillow, the friendly fork of Pile, assists in steganography analysis by enabling pixel-level inspection of image files to detect hidden data, while PITSC3 provides Python bindings to the sleuth kit for forensic analysis of disk images and file systems. The YARA-Python integration allows ethical hackers to leverage the powerful YARA pattern matching language to identify malware families or suspicious code patterns during security investigations. Python-Registry grants access to Windows Registry Hive files for forensic examination of system settings, user activity, and potential evidence of compromise. For network traffic analysis, DPKT enables low-level packet dissection and flow analysis that complements higher-level tools like Wireshark by allowing custom processing and statistical analysis of packet capture files. PyShark serves as another valuable network analysis tool that provides Python wrappers for TShark, the command-line version of Wireshark, allowing programmatic filtering and processing of complex packet captures. The PyPDF2 and PyXPDF libraries assist in analyzing PDF documents, a common attack vector, by enabling inspection of embedded objects, JavaScript, and other potentially malicious elements that might be overlooked by standard viewers. Password auditing and recovery represent another critical area where Python libraries shine, with HashLib providing implementations of major cryptographic hash algorithms needed for password cracking, while PassLib offers comprehensive password hashing framework, supporting over 30 schemes commonly encountered during security assessments. Johnny bridges Python with the legendary John the Ripper password cracker for programmatic control over brute force and dictionary attacks. For wireless security testing, Scapy again proves invaluable for crafting and analyzing 802.11 frames, while PyREBox provides Python bindings for wireless card manipulation, essential for conducting wireless penetration tests. The PyExfil framework deserves mention for testing data exfiltration techniques by implementing numerous covert channels that ethical hackers can use to assess network monitoring capabilities. PyMetasploit and Python-Exploit-DB integrate with established security resources, allowing programmatic access to Metasploit modules and exploit database entries respectively, enabling automation of vulnerability verification processes. PyVulnDB provides similar functionality for accessing vulnerability information from various sources in a structured format. For social engineering simulations, PyPhisher offers templates and automation for conducting controlled phishing campaigns to assess organizational resilience, while SocialFish provides a framework for creating credential harvesting pages that mimic popular services, strictly for authorized security testing purposes. The true power of these libraries emerges when combined in custom scripts tailored to specific security assessment scenarios. A skilled ethical hacker might use Scapy to craft custom packets that bypass IDS systems, analyze the results, with DPKT correlate findings with Python-Nmap scans, then develop an exploit using Pwntools, all while maintaining detailed logs through Python's built-in logging facilities. Python's interactive nature through Jupyter Notebooks further enhances these capabilities by allowing security professionals to document their methodology with executable code snippets, visualizations, and narrative explanations, an approach particularly valuable when findings need to be presented to technical and non-technical stakeholders. The ecosystem continues to grow with emerging libraries like Frida for dynamic instrumentation of running processes, Pyre for reverse engineering binaries, and PyArmor for analyzing obfuscated Python code. What makes Python particularly suited for ethical hacking is not just the availability of these specialized libraries, but the language's emphasis on readability and rapid prototyping, qualities that enable security professionals to quickly adapt tools to novel attack vectors or defensive techniques. As cyber threats evolve at an accelerating pace, Python's rich library ecosystem ensures ethical hackers have the tools needed to stay ahead. Whether they're conducting vulnerability research, penetration testing, incident response, or developing new defensive methodologies. The libraries mentioned represent just the tip of the iceberg in Python's security toolkit, with new specialized modules constantly emerging from the vibrant open-source security community to address the latest attack techniques and defensive challenges in our increasingly interconnected digital landscape.